Hello students, welcome to my channel. In this video, we will study about the relative intensity of hyperfine lines. Okay, we will take an example of methyl radical to explain this concept. Methyl radical can be represented like this, CH3 and carbon is having free radical. Now you can see here is that only one unpaired electron is present on a carbon for which the spin will be 1 by 2. Okay, for one unpaired electron we know S will be 1 by 2 and ms value is the quantum number associated with the spin of the electron, and we know that its value is from minus s to plus es. That means we have two values, that is minus 1 by 2 and plus 1 by 2 for the methyl free radical. Okay, now we need to consider the nuclear spin. Okay, this is the electron spin. Now we have to consider what? Nuclear spin. Okay, the nuclear spin can be represented by a capital I, right? This is the nuclear spin, and we know that for hydrogen, okay, for one hydrogen the value of I is 1 by 2. Okay, the I value for an hydrogen atom is 1 by 2. Now if you look here, there are 3 hydrogen present in the methyl radical. Therefore we need to consider the I value for all the 3 hydrogen atoms. Okay, so I call it as effective I value or effective nuclear spin. Okay, effective nuclear spin will be what? It is a sum of nuclear spin of all the 3 hydrogen atoms. Okay, since we had 3 hydrogen here, so we need to add the I value for each hydrogen. Okay, we will get 3 by 2. Okay, 3 by 2 is what? 3 by 2 is nothing but a effective I value, nuclear spin. Okay, now we need to consider Mi. Okay, we need to consider Mi. Mi means what? It is the quantum number associated with the nuclear spin, or simply called as nuclear spin quantum number. Okay, while Ms means what? It is a quantum number associated with the spin of the electron. Okay, now just like to this Ms, Mi value is given by what? Minus I to plus I. Okay, so now how many values are there? That is from minus 3 by 2 to plus 3 by 2. So now write what are the values are there. Minus 3 by 2, minus 1 by 2, plus 1 by 2 and plus 3 by 2. So there are 4 Mi values are there for the methyl free radical. Okay. Now what we need to do is we will be writing now energy level diagram. Okay, energy level diagram. Okay, for the methyl free radical. Okay, first we need to write the ms levels in the absence of magnetic field. Okay, I have already said here there are 2 ms values for the methyl free radical. That is why I am writing 2 lines indicating that this is ms plus or minus 1 by 2. Okay, both are degenerate in the absence of magnetic field. Okay, H is a magnetic field. In the absence of magnetic field, we know that both the levels will be degenerate. But if you apply the magnetic field, H not equal to 0. Okay, what is H not equal to 0 means? In the presence of the magnetic field, what happened? The degeneracy of the ms level will split. They split into like this. Okay, this is ms is equal to minus 1 by 2. This is ms is equal to plus 1 by 2. Okay, now after this what we need to consider? We need to consider the hyperfine splitting. Hyperfine splitting. Okay, so because of hyperfine splitting, what happens? These ms levels further splits. Okay, it splits into how many levels now? It will splits into 4 levels. Okay, how many Mi values are there? No, to that many level this ms level also splits. Now here for methyl free radical we have 4 Mi values. That means each ms level will split into 4. Okay, let me write here. Similarly this level also splits like this. Like this. Okay. Now this value, this level is Mi is equal to plus 3 by 2, while this is Mi is equal to plus 1 by 2, this is mi is equal to minus 1 by 2, this is mi is equal to minus 3 by 2. Well, here mi will be minus 3 by 2, just a reverse of this. Okay, the mi is equal to minus 1 by 2, mi is equal to plus 1 by 2, and this is mi is equal to minus 3 by 2. Okay, sorry, plus 3 by 2. Okay, now how many transitions possible for methyl free radical? To that we need to consider the selection rule. Selection rule. So what is the selection rule in ESR spectroscopy? We already know the selection rule is delta ms is equal to plus or minus 1 and delta mi is equal to 0. This is the selection rule we are following in a ESR spectroscopy. Now considering this selection rule, we can say that how many transition? There are mainly 4 transition. That is this, then what, this one, and let me write here this transition, and finally we have this transition. Okay, this is the first transition, second transition, third transition, this is the fourth transition. Okay, let me write how many transitions are there. There are 4 transitions. So what are they? That is from mi is equal to minus 3 by 2 to mi is equal to minus 3 by 2, and mi is equal to minus 1 by 2 to mi is equal to minus 1 by 2, and mi is equal to plus 1 by 2 to mi is equal to plus 1 by 2, and finally mi is equal to plus 3 by 2 to mi is equal to plus 3 by 2. So there are 4 transitions possible in case of methyl free radical. Now we know that there are 4 transitions. That means we should get 4 lines in the ESR spectrum. That means if you consider the spectrum, ESR spectrum, how many lines we should expect? We should expect 4 lines. Why? Because there are 4 transitions are possible for a methyl free radical, and we should expect 4 lines. Now question is that whether the intensity of these 4 lines are same or different. Okay, that is what we are studying here. Okay, we need to study what is the intensity of these lines observed in a ESR spectrum. Okay, to explain that, let us consider, okay, let me write here, let us consider mi is equal to plus 1 by 2 by upward arrow, and mi is equal to minus 1 by 2 by downward arrow. Okay, what we are doing? We are now getting to know what is the intensity of these hyperfine line, whether it is same or whether it is different. Okay, for that reason what I did, I just considered mi is equal to 1 by 2 as a upward spin like this. Okay, while mi is equal to minus by 1 by 2 as a downwards arrow. Okay, now write how many mi values are there. Okay, now we know that there are 4 mi values are there here. Okay, minus 3 by 2, minus 1 by 2, plus 1 by 2 and plus 3 by 2. There are 4 mi values. I am writing that 4 mi values here. That is plus 3 by 2, plus 1 by 2, minus 1 by 2 and minus 3 by 2. Okay, these are all mi values for the methyl free radical. Now what you need to do is you need to represent 3 by 2 and these mi values in terms of arrows, downward or upward arrows. Now in order to get 3 by 2, okay, you know that 1 by 2 means what? 1 by 2 means upward arrow. Okay, now you need to get 3 by 2. Okay, you need to represent that by means of arrows. Okay, whether it is upward or downwards. Okay, now in order to get 3 by 2, how many arrows are required? All arrows should be upward. Then only you get what? 3 by 2, because this means 1 by 2. Similarly, this arrow means 1 by 2 and this arrow is also 1 by 2. If you add them, what you get? You will get 3 by 2. Okay. Now check whether there is other possibility to get 3 by 2. Like you can just shuffle them. You can do like this, or you can check it by putting the upward and downward arrows. If you get 3 by 2, you can write here. But here you are not able to get 3 by 2. So there is only one possibility for a plus 3 by 2. Now check for plus 1 by 2. Okay, plus 1 by 2, how can you get plus 1 by 2 by arrows? Okay, you need to put 3 arrows. Okay, even though I written here plus 1 by 2 means upward arrow, you are not supposed to put only one arrow, because in the methyl free radical there are 3 hydrogens, right? So we need to have 3 arrows. Okay, okay. Now in order to get the plus 1 by 2, the arrangement should be like this, correct? This is the one arrangement. Why? Because this means what? 1 by 2 plus 1 by 2. This is also plus 1 by 2. This is minus 1 by 2. Now here you can see 1 by 2 and minus 1 by 2 cancels each other and you left with only 1 by 2. Right? So now check the other possibility. Other possibility means what? You are just interchanging these arrows. Okay? Like this. Now similarly, you have another possible arrangement. Okay, now check, do you have other arrangements? You do not get any other arrangement to get to the plus 1 by 2. So there are only 3 arrangements. Similarly, do for minus 1 by 2. Minus 1 by 2 means one should be downward arrow and other should be like this. Okay, because these two cancel each other and you left with only these two. Okay, let me do another possible arrangement. This one. Okay, this is minus 1 by 2 and these two cancels with each other. Okay, this one, this is another possible arrangement, because this is plus half, this is minus half, get cancels and you left with the minus 1 by 2. Okay, now check, do you have other arrangement? Do you have any other arrangement? Just arranging the 3 arrows, you should able to get that mi value. Okay, I don't think you will get the other arrangements. Okay, for the minus 1 by 2. Okay, I stop here. Next, for the minus 3 by 2. Now in order to get minus 3 by 2, all arrows should be downward. Then only you get minus 3 by 2, because this is minus 1 by 2, this is minus 1 by 2, this is also minus 1 by 2. If you add them, it is minus 3 by 2. Okay, only one possibility is there for minus 3 by 2 as well as plus 3 by 2, because there is no other arrangement of arrow you can do for this. Okay, now I write here one arrangement. Okay, one arrangement. Here how many possible arrangements are there? 3 possible arrangement. Here also 3 possible arrangement. Here how many arrangement? Only one arrangement. Okay. Now we can say that we get 4 transition, right? We know that there will be 4 transition. Now what is the intensity? The intensity of those 4 transition will be 1:3:3:1. Okay, 1:3:3:1. Okay, that will be the intensity of the 4 transition for the methyl free radical. So how do you get? You will be getting 3:1. Okay, this is 1, 3, 3, 1. Okay, this is the relative intensity of a methyl radical. Okay, if you have any doubt in this class, you can ask me in the comment section. Okay, in the next class we will look into the relative intensity of the nitrogen molecule. Okay, N2. Okay, by considering this particular example, we will see what is the intensity. Okay, like this we will be showing the same thing for the nitrogen molecule in the next video. Okay, thank you for watching.